So, in this week we will be discussing about hazards. So, hazard, how do you identify hazard, how do you analyze it and how do you manage the hazard. So, primarily it is a very simple topic, but it is a very critical topic and it is an important safety program when you see when you want to have a zero accident in construction site. Okay. And most of the hazards these days are all handled and managed very easily with the help of building information modeling. Okay. So, I have also brought in one or two experts who have worked in this topic. So, they would be sharing a small presentation on building information modeling and safety related issues. Okay. So, you can go through that. So, this topic, this lecture primarily I will be focusing on the theoretical portions and aspects of hazard management. So, what is a hazard? Many of these issues are all known to you because this was discussed in the first week of the lecture itself. Hazard is an unsafe physical condition that is always present in any construction site. Okay. So, this hazard is actually in one of the three modes. One is called dormant, second one is armed and the third one is active. Dormant is it will not cause any harm. Okay. It is there available, but it is not in the pathway where the workers are moving in, or it is not visible to the workers. Okay. But the hazard is still there. For example, reinforcement stored in a far off place, the hazard is not removed. Okay. The hazard still exists, but the workers are not frequenting to that area. So, that is primarily called dormant hazard. Armed, it can cause harm to any worker. Okay. For example, there is a gap in the walkways. So, this wherein workers are moving, walkways are primarily meant for workers to move along. So, these gaps can actually can pose hazards. Okay, when the workers are frequenting that area. Active is maybe there is a large water body here and there is an water body in the sense water has spilled over and is there, and there is an electric wire which is passing on. Okay. So, this is primarily an active hazard. It can cause injury, death, damage any time of the period. So, two important aspects you may have to look into the hazard. One is the likelihood of the occurrence and the next one is the severity of the consequences. A safety engineer or a safety supervisor should have the expertise to identify hazards. So, primarily if this is the tasks planned for the particular week, he should be able to identify what are all the critical operations to be carried out and what are the different hazards seen in those critical operations and what is the risk of or harm those hazards can create. Hazard and risk has a little difference in meaning. Okay. So, risk also poses the hazard, the dangerous situation plus the exposure to the dangerous situation, that is measured in terms of risk, and inform all levels the magnitude and peril the hazard can create and define safe design criteria or construction methods to eliminate or at least to try to get rid of the hazard. So, what is the current situation? Okay, most of the accidents happening today, this also we have discussed in the chain of events theory or domino theory, actually is a result of one factor wherein a person was identified as a causal factor with which the accident has happened. But if you start analyzing the root cause of the accidents, the direct, indirect cause, the tertiary cause and so on, it would be like some management situation, some hazard present in the project and the construction site which made the worker to behave in a different way and resulted in an accident. Okay. So, this you would have noticed when we discussed the theory long back. Okay. So, now if you see as a result of the accident somebody got injured, then it comes to litigation or an arbitration, it comes to court trials. So, at that time if you see many of the evidences related to the hazards all would have been collected, documented and so on, and they would be presented in the before the court trials also for evaluation and proceedings. Okay. At that time if this knowledge, okay, or I would say this learning of the hazard assessment is known to everyone, then they can also manage the hazards better. Okay. What happens is once the court trials are all over, these are all stored or archived. Okay, in some files and they are not actually meant for opening it to the public. Okay. So, what happens is the learnings that are all happening. So, these court trials, no, they actually no don't maintain a set of database for the for maintaining a safety. If you want to have a good safety planning, then all these documents can be a real good source for identifying and the possible hazards, and you can also think of the probable solutions, and you can think of how to manage economically and also within the time and cost. So, construction safety planning is the key to preventing accident hazards which prevent injuries, which prevent litigation. So, efforts of construction industry seems to be spent on defending hazardous circumstances over and over again from courtroom to courtroom. So, from every course, maybe the same situation in a different angle you would be arguing in a different court, but since the proceedings are not revealed to the public, so you are not right now the trend is improving, but still all these cases if they are becoming transparent, then obviously you can easily achieve the zero accidents in construction sites. After the trial is over, the information is locked away forever in court records and nothing ever is done to save others workers' lives. So, no formal means or mechanism to collect and summarize the hazard information developed in personal injury litigation. Okay. So, complete database may not be obtained, but even that may be like a exhaustive database that have been collected, even that is not opened up for the public. All hazard data developed by the litigants in discovery should be made open to the public to let all available hazard information stand the light of the day. So, the vital information lies buried in court archives and the construction industry is kept in the dark with repetitive accidents and hazards repeating in the construction industry. So, lawyers who initiate the protection orders request isolation of experts during hearings. So, they are in general are the main hindrances to safe construction planning. So, it is unwise to keep a hazard because you have to pay for the harm it causes, but when you pay to remove the hazard it makes you spend little money, but when you do not pay to remove the hazard and you wanted to save that money, you have to keep in mind one day you are going to pay too big. Okay. These all we have discussed earlier also. Types of hazard. So, these are some list I have brought it from literature. So, natural or environmental, structural or mechanical, electrical, chemical, radiant, biological. So, like this you can list out the hazards seen in any construction site. Natural or environmental, gravity, falls, impact, slopes, rollover or sliding, water, sinking or floods, atmosphere, wind, glare and so on. Structural or mechanical, surfaces, instability, ladders, rotation, wheels or pulley, compression, structural failure, shearing, vibration, noise, dislocation, pneumatic on blown objects, metal fatigue, tension spring, confined space and so on. Electrical, voltage, alternating current, DC current, direct current, ground, capacitance and so on. Chemical, combustion, fire, corrosion, toxic liquid, exothermic and endothermic reactions, then decomposition and so on. Radiant, sound, heat, light and etc. Biological, venom, infectious agents and allergens, and automated system hazards wherein the system can cause a failure and you may do wrong handling of materials inside. So, these are all the different types of possible hazards. So, how do you analyze the hazard? Okay, there are series of steps. First, you have to look at the project as a whole. So, in the project it is very difficult to foresee a 5-year project and analyze all the hazards, probable hazards, okay. But you can understand based on your previous experience where all major accidents can happen. So, those all phases can be identified. Okay. Maybe there may be 4 or 5 major operations. If you look at an apartment construction, you may have excavation, foundation, superstructure, then concreting. So, like this you can differentiate the major activities and identify where the maximum number of accidents have happened in the past. So, that you can analyze and that you can take it up as a phase hazard analysis. So, that operation you can study in detail and look at the number of series of sub steps, and that you can pick up 1 or 2 okay, as a job hazard analysis or job safety analysis. There you have to go through 4 different steps, and those 4 different steps will help you to identify and think of how to manage the hazards. So, this is hazard analysis is a technique used to determine the workplace for hazards with the potential to cause accidents. The workers are trained in hazard identification and asked to recognize and report the hazards for evaluation and assessment. So, project hazard analysis should be performed prior to start of the work. All these hazard analysis should be done prior to start of the work, and during the project execution also you have to do safety walk inspections, okay, or we say walk-through inspections, okay, safety inspections. If you have a building information model, you can also do safety walkthrough virtually, okay, before the construction starts. So, should all be done. So, project hazard analysis can be identified with the help of the project safety plan, okay. With that you can partially identify what are all the different hazards linked with equipment, linked with major operations. Is easy for you to pick out. So, anticipated phases are all identified. The types of hazards linked with each phase you can really link it up. Control measures to some extent you can foresee in the design phase and partially in the construction phases also. Phases and specific operations that will require further analysis you may have to identify and narrow it down, okay. So, now among the list of 20 list of operations, at least you will identify 1 or 2 for critical analysis on hazards, and then you may have to narrow down to zoom in. So, this phase hazard analysis may be performed only for those phases of the project for which the project analysis has identified the need, okay. From this you are going to the next level. It is performed again prior to start of the work on that phase of the project. So, the project can continue only before the start of that particular phase you may have to do the analysis, identification of specific work operations or procedures, and evaluation of hazards linked with specific chemicals, equipment, material, procedure used or present during the performance of that phase of work, identification of specific control measures necessary to protect workers from the identified hazards. All those will be studied here. Okay, once you have thoroughly done that mapping and phase analysis is partially clear, so you may have to do the job safety or job hazard analysis. Both are almost the same. One is identifying the hazards, another one is safety analysis. So, in a way you are identifying the hazard and you wanted to provide a situation of complete safety in each of the construction operation. So, in short form it is referred as JSA, job safety analysis, or JHA, which is job hazard analysis. Successful accident prevention method proven very effective in the industry to identify potential hazards and to recommend the safest way to do the job. Jobs that should have the JSA or JHA conducted are some hint on how do you select the tasks, okay. Jobs which have highest injury or illness rates, jobs with the potential to cause severe or disabling injuries even if there is no history of previous accidents, jobs in which a small human error can lead to a severe accident or injury, jobs that are new to the operation or have undergone changes in the processes or procedures, jobs complex enough to require written instructions. For all these, then you may think of doing the JSA or JHA. It is a basic approach to develop improved accident prevention procedures by documenting the first hand experience of the workers and supervisors, and at the same time to instill the acceptance through worker participation, because the workers are the one who are actually linked with safety. So, when you involve the workers, then you may also get a better solution to handle a safe analysis. Okay. So, now you to perform a JSA or JHA, the following questions can be asked and you can get the answer. So, first what you should do is you have to, so this is actually a photo taken from a website. So, you have to look at all the hazards from 6 directions, okay. One is from the top, okay, one is on the front, the back, then on your sideways, okay, 2 sideways. So, and one on the ground which is below your space. So, you will have 6 directions to look through for any of the operations a worker is performing, and accordingly you may easily be able to identify all the hazards present in the construction operation. Some of the sample questions: what can go wrong, what are the consequences, how can it happen, what are the contributing factors, how likely is it that hazard will occur. The answers can be, again they are the probable answers. Can any body part be caught in or between objects? Do tools, machines or equipment pose any hazard? Can the worker make harmful contact with the moving objects? Can the worker slip, trip or fall? Can the worker suffer strain from lifting, pushing or pulling? Is excessive noise or vibration a problem? Is a worker exposed to extreme heat or cold? So, if you look at all these topics that we have discussed earlier, you may have to look in any of these 6 directions, then you can easily identify all the hazards. Okay. Now, there are 4 steps as I told you to easily do the JSA. Number 1 is selecting the job to be analyzed. Okay. Some tips for identifying that we have seen earlier. So, jobs which were not run routinely, but still a simple error can pose a real accident, and jobs that were done infrequently. Like this, you can choose a priority on the jobs for hazard analysis. So, establish a methodology to prioritize and select the jobs. Before the project starts, you have to have a wise decision on how to prioritize activities for hazard analysis, because you may not be able to do for all the activities in the construction site. So, jobs have to be ranked in the order of greatest accident potential. Some criteria which can be used are accident frequency, a job that has repeatedly produced accidents, job severity. A job may not have produced too many accidents, but it would have got a severe injury rate, in the sense a serious accident. Judgment and experience, many jobs qualify for immediate job safety analysis because of the experience. Okay. I know this particular job is really hazardous. So, maybe it is not caused any more number of accidents or any severe accident, but still based on my gut feel and judgment, I know this can cause a serious. This has to be evaluated. New jobs, non-routine jobs or change in jobs. For the jobs that have never been done at a particular work site, hazards might not be fully known, because the workers may have lost the memory or on how are the hazards available and so on, and what are the safe inspections that they have to carry out, they may have forgotten. So, it is better to do that. Routine jobs, in routine jobs the employee may be exposed repeatedly to certain number of hazards, that also you may have to assess, okay, if it is a routine job. So, first one is selecting the job, okay. The next, separating the job into its basic steps. For example, it may be even loading, unloading of steel reinforcement. This example I have covered earlier also. So, for this you may have at least 50 steps at least, okay. The truck may have arrived at the site, then you call the engineer for weight checking, then they take the weight of the entire reinforcement, they enter the register, okay, and then maybe they do preliminary test there if required, and then the truck enters the site, and again you wait for the workers to unload the reinforcement, and again a register is entered as to know in the certain godown where is the reinforcement arrived at, and again make this, that, and characteristic features of those reinforcement, and some sample may be taken for experiment again if required. So, and then what happens is the empty truck returns back. Okay. So, like this there may be a series of steps. Okay. You may have to separate the job, identify one operation, loading and unloading of reinforcement. You will have to break down the job into number of basic steps. Logically, a job should be broken down into basic steps. Only if you break down the step, you will know where the hazardous steps lies in. So, each step or activity should be briefly describe what it has to be done, and what you have to do is the basic steps should not be omitted, but you should not be having too many details. Okay. For example, loading and unloading itself, if you have almost like 50 or more than 70 or 80 basic steps, obviously you are going to, if you are doing the same way all the operations, then you may not be even able to analyze the hazards completely. Okay. So, keep it as minimal as possible, but at the same time identify all the hazardous tasks, in the sense let the hazardous tasks be revealed out. Okay. That you may have to keep in mind. The first step, how do you do is, maybe you may have to do a walk around inspection, and you have to break down the list into manageable number of steps. So, preferably keep 10 to 15 steps, because you can easily identify all the hazards if you are keeping it very simple and small. The third step is identify the hazards linked with each step. Now, you have listed out all the 10 to 15 steps, maybe in one particular operation like concreting or shuttering and de-shuttering and so on. Then it is easy for you to identify the hazard linked with possible hazard, you can easily think about it. After all the basic steps of the operation or the job procedure has been listed out, each job step should be examined to identify the hazards linked with it. Some hazards are more likely to occur than others and some are more likely to produce serious injuries than others. So, that you have to identify and do. The last step, eliminate or control the hazard. This we will see what is a managerial step of managing the hazard. There are many ways to eliminate the hazard. Maybe you can modify the existing process, you can substitute with the less hazardous substance or improve the environment, okay, improve or maybe promote safety, more safety measures and so on. So, find a new way to do the job. If the sequence of job steps or the deviations from established job steps are critical to the safe performance of a job, then this should be noted down in the JSA and you may have to think of finding out an alternate way. If the physical condition is what is creating the hazard, then you may have to think of improving the site conditions so that the hazards are easily carpeted in, and change the procedure to eliminate the hazard, reduce the frequency of performing that specific job. So, in the sense reduce the exposure to the hazard or contain the hazard with enclosure, barrier or guards. Maybe one equipment is not working and it is posing a hazard, maybe you can put a small fence so that people are not going towards it. And the last one is use PPE as a personal protective device. Okay. So, this we will see here. So, this is actually an hazard management. Okay. If you see here, this is actually a 5-step process on how to manage the hazard. For number 1, elimination, which implies remove the hazard. Number 2, substitution, replace the hazard. Number 3, engineering controls, isolate the workers from the hazard. Administrative controls, change the way people work. Last one is PPE, protect the workers with the PPE. Okay. If at least this will minimize the damage to the workers. Okay. So, now what are these? This is focused to do something with the hazard, maybe prevention through design or safe constructability that we have discussed in the designers. No? In the first or second week we have discussed, that can be able to help us with elimination and substitution. If you think the way you use concreting is creating a problem, maybe you can think of a steel structure with the glass facets or maybe modular construction or maybe prefabricated construction wherein mixing of concrete in the site is totally avoided. So, you can think of lot of ways of eliminating the hazard and by substituting it with another material or at least changing the way it can be done. The last 3 steps are generally to do with the way the hazard is exposed out. Okay. So, suppose if a worker is wearing a hard hat, okay, maybe the falling objects or something may not give him a serious brain injury or a head injury, but it may be a partial injury to him. Okay. So, at least the impact level of the hazards can be minimized. Okay. So, that you can surely do. So, these are the 5 steps. Okay. I will show you with examples for the first 1 or 2 steps. This is a modified methodology to reduce the hazards. Okay. So, handling of MS beam in reinforcement. So, some analysis was done in one of the local projects in Delhi. So, handling of MS beam in steel work. So, hazards can be trips, fall or hit by injury. So, original procedure was manually done, okay, chain pulley block system was used. So, then later on modified procedure just for promoting the safety, tower crane was used for handling. Builder hoist operation, fall of person or material, this is a builder hoist. So, the original procedure was handling of materials with the builder hoist. Then the modified procedure was use multifunctional hoist, which is shown here. Okay. Builder hoist operation again, hit, injury and crushing. So, unguarded rotating parts. So, again suggestion is use a multifunctional hoist. Builder hoist erection processes. So, during erection you may have a hoist collapse. So, original procedure was with the builder hoist, again modified procedure is suggest using a multifunctional hoist. So, all the 3 hazards can be eliminated when you shift the procedure of the work itself. Build and hoist erection, the mast may fall due to loose soil. This is primarily called as a mast. It may fall if the soil is very loose. The original procedure was compacted down floor. The ground was compacted and then the mast was laid. The revised procedure is try to put a PCC on the ground floor so that the ground floor is very firm for the mast to not fall down. Erection of scaffolding. So, this is a old tubular jallies which was used. So, there was an hazard on toppling of the jolly itself, fall of person from there, and this is a new walkway jolly and which is firm and fixed with all guardrails. So, this was treated as an equivalent for the old processes. Concreting with pump, this was hit by pipeline because a pipeline was fixed with ropes and clamps and there were hazard related to that. So, just because of safety promotion was there, so people were started using on static boom placer, okay, with which the concrete was placed and this hazard was completely eliminated. Okay. So, these are primarily elimination and partially the examples I shown here and partially they are actually substitution also. Some more examples on how to maintain a safe processes. This is again can be called as a safe operating procedure. Like this you can create a safe operating procedure for all the operations, so that you need not have any hazards all can be revealed out in the whole processes. Site clearing and bush clearing. So, manual clearing, you may have leg injury, you can use gum boots and complete clothing, or you can choose machinery for clearing. Snake bite in the grassy area, maybe the carbolic acid can be sprayed before the work start and gum boots can be worn so that snake bites can be avoided. Leveling by man and machinery, equipment injury. So, check the fitness of the equipment with respect to safety aspects before use. Mishandling equipment and accident, operator identity required. So, you should not allow unauthorized operators to operate the vehicle. Run over on people resting under vehicle. So, before you start the machine, see whether any people are there down, or else you can also provide rest shed for the workmen. Hit underground utilities, get the clearance from the concerned department, identify all the utilities and then only you may have to do. In a way, work system required and expose the utilities. Insulated materials also should be used before you start digging. Okay. Overhead power lines, erecting goal posts with warning signs. Also you can put adequate fencing so that the vehicle movement is restricted. Excavation, damage to underground electrical, telecom cables and water services. Follow excavation clearance permit system, look for route markers, make trial pits in case of doubts, look for warning tapes, cable covering mats, concrete saddles or sand paddling, adhere safety to manual excavation in case of presence of underground cables. Fall of vehicle into the excavated pit, provide hard barricades with minimum clearance of 2 meters from the excavated pit. Ensure adequate illumination and danger lighting, post reflective warning signs and blinkering lights to highlight the deep excavation. Fall of person into the pit while walking or working, provide barrier away from the edge of excavation, provide signboards and blinking lights. Fall of objects into the excavated pit, no material should be stacked at the edge of the pit, minimum 1.5 meter clearance should be given. Congested work site, too many person working into the trenches, provide adequate emergency access, allow only minimum required number of person to work at the same time. Earth moving equipment operation, keep minimum distance of 5 meters between two equipment in use, use only authorized equipment and employ experienced operators. Ensure safe overhead distance that can be maintained, otherwise close the activity and you have to postpone the activity later. Ensure strict supervision in case of equipment. If you see all these hints are all picked up from the earlier topics, okay, when we were discussing about each and every topic on excavation and so on, we have discussed several issues there. Okay, from there you can pick out all these and you can easily write a safe operating procedure so that workers will be very clear on how to do. Okay. So, this is a sample I brought out on excavation. Like this you can bring it out for each and every topic. The basic standard of care, To avoid the hazard, you must rely primarily on the physical elimination of each hazard rather than human performance. So, if you do not remove the hazard is still available there. Okay. So, primarily the first two what we have talked in hazard management, eliminating the hazard and substituting the hazard are the best procedures wherein the hazard is not coming in the scenery at all. Okay, in the all the other three steps, okay, you are only trying to minimize the impact that was caused by an hazard. Any hazard that has the potential for serious injury or death is always unreasonable and always unacceptable if reasonable design features and or the use of safety appliances are available to prevent the hazard. So, the key to successful safety engineering is identify and design out as many hazards as possible and rule out from the processes. Identification is a basic building block for ensuring inherently safe construction project. If you are not able to identify, then it is very difficult for you to proceed with hazard analysis at all. Okay. So, the most puzzling process is how an engineer can initially identify a hazard and how a potential hazard is recognized at the time of design and at the time of construction planning. That is all the real challenge here. Okay. So, during the design itself you can think of alternate procedures. Okay, you can think of alternate ways to change and handle a hazard. In construction, suppose if the design is fully done also, during construction at least some sort of substitution measures and elimination measures can be really brought in. So, if you are not vigilant at that time, okay, and you wanted to do safety control measures after you have planned design and construction, then you are actually too late. You may have to manage with PPEs or administrative controls or the other controls. So, that is the only one option you will have. Okay. Now, let us quickly wrap up this. So, this is actually a recap on hazard control. Workplace procedures adopted to minimize injury, reduce adverse health effects and control damage to plant and equipment. So, this is a hierarchy of control: elimination, substitution, engineering controls, administrative controls and PPE. So, this is primarily in the way of increasing effectiveness. Elimination is the best effective method. This is increasing participation and supervision needed, okay, if you want to go in the reverse order. Controls are usually placed most effective to least effective, okay, at the source, along the path and at the worker. So, you may have to think of this particular path. Elimination, remove the hazard from the workplace. Elimination is a preferred way to control a hazard and should be used whenever possible. Substitution, substitute hazardous materials or machines with less hazardous ones. Okay. Then engineering controls, design or modifications to plants, equipment, systems and processes that reduce the source of exposure. Automate the hazardous processes, use mechanical lifting devices or transportation instead of manual methods, enclose and isolate the hazard from workers and so on. Administrative controls, controls that alter the way the work is done. Implement job rotation and work rest schedules that limit the time a worker is exposed to a substance or processes. Establish safe work practices such as standard operating procedures, emergency response training, good housekeeping, personal hygiene practices and so on. The last one is PPE. So, it should be the last level of protection used when all other methods are not possible. Okay. If you see here, the steps: identify the hazard, assess the risk, choose the best control for the hazard, implement the chosen control and evaluate the effectiveness of the control. Okay. The last we have come to the end of this course. So, acknowledgements, I am very grateful to acknowledge so many people and so many sources from which I have developed this 8-week course material. So many books I have referred and everywhere then and there I have given the references, and also in the main page of the course page itself I have given so many list of books and lot of OSHA material I have taken up and several IS codes, and at the end of each and every lecture I have given in the last slide what are the list of IS codes and all other reference material, okay, without which I would not have been able to finish this lecture. And there were so many experts thankfully who came forward to deliver a small short safety talk, and which will be not for evaluations in the examination, but without that this course may not be a complete package. Okay, so thanks to Mr. Jaimin Mehta, and he is from ACOM, Dr. Amarnath, he is from L&T, Lieutenant Colonel Arun Shekhar from MES, Mr. Karthikeyan is a freelance person working in an industry, Mr. Jigar Mehta again from L&T, Lal Krishna from DMRC, Ujjwal Mishra, Vidit, Jaiswal, Priyanka, all these my students, still they are working as an in some small projects. And the TA students, Priyanka, Anikesh and Venugopal, for helping me in preparing slides and making so many photographs and into life, okay, by drawing it on 3D forms, and for editing and for helping me in the video sessions and assignments and discussion forums. And the photos were shared by so many of my MTech students and research scholars, and at last to the NPTEL team and to my students for this wonderful time. Thank you. I hope you would have enjoyed.